So we're back here again, and before I continue, I'd like to first define the first ionization energy. So that the first ionization energy is the energy needed to remove 1 mole of electrons from 1 mole of the gaseous state of the ground state of an element. So you can see here the graph. I'll go on to that later. So why is there an increase in the successive ionization energy after the first ionization energy? Because essentially, as the first ionization energy removes 1 electron, which means that if there's 1 less electron, that means there's less shielding from other electrons. There's less shielding from other electrons, meaning that since electrons have the same charge, they will repel from each other. So that means when there's 1 less electron, there's 1 less negative charge to repel, meaning that there's a stronger force of attraction between the positive nucleus and the outer electrons, which can be ionized. Meaning that since there's a stronger electrostatic force of attraction between the positive nucleus and the negative electron, then more energy is needed to ionize the atom or remove the electron from the orbit. So that's basically the basics of why successive ionization energy increases on 1 energy level. However, if the successive ionization energy, if the ionization moves from 1 shell to another, for example, from the 3rd shell to the 2nd shell, the ionization energy will increase as the actual electrons are closer to the nucleus, to the positive nucleus, which means that there are stronger forces of attraction between the positive nucleus and the negative electron, increasing the energy needed to ionize the atom or ionize the ion even more, basically meaning that remove the atom. They remove the electron, sorry. So why does the ionization energy increase from the left to the right side of the period on a periodic table? So essentially what happens is that as you move across the period to the right, the atomic number increases, which means that the actual positive charge in the nucleus increases as there are more protons, which means that more energy is needed to remove the electron as there's stronger force of electrostatic force of attraction. However, with everything, there are exceptions. So why is there a decrease in the first ionization energy between beryllium and boron in period 2? Essentially what happens is since beryllium is in group 2 and boron is in group 13, they're in 2 different sides of the periodic table, as you well may be familiar with. There's kind of a gap in the periodic table, and essentially what happens is that the electron configuration of the group 2 elements is ns2 because there's only 2 electrons in the 2nd or 1st shell, depends.